warm welcome from my side as well. Unlike the former presentation, I'm talking to you about hardware, not software. I would like to introduce the vacuum ice slurry technology, which can be used, for instance, for cold thermal energy storage, but also for heat pump applications. We call it aquathermie. So first I would like to show you what does it mean and how does it work, vacuum ice slurry. All of you know probably ice cubes, which can be manufactured in a household using a freezer. And we are doing ice production on a much larger scale and much more efficient because we have lower temperature differences, which are decisive for a heat pump process. So you see here a vessel, and in the lower part of this vessel, there is a water filling. And above the water, there you have water vapor, and this water vapor will be sucked and compressed by a special turbo compressor to a higher pressure level. Then the water vapor is condensed again. And by removing the water vapor from this space, the evaporation of water will take place at the surface. And for this evaporation, heat is needed. And this heat comes out of the water. So it means that using this process, the water will boil, but this boiling process takes place at a temperature of 0 degrees. And how does it work? It works when you lower the pressure down to 6 millibars. So at this low pressure, water already evaporates at 6 millibar and 0 degrees Celsius. And this, of course, is also the freezing point. That's why this process is also called the triple point process. So you have water in all three phases. You have liquid water, you have water vapor, and you have solid water, which is ice. This ice is created here on the water surface. By mixing this water, over time you create what is called ice slurry, which is a pumpable mixture of water and ice particles. And this mixture is then just pumped out with a conventional pump and can be used and can be pumped to a storage and then later on used, for instance, for cooling. So what are the advantages of this process? It has the highest efficiency of all ice making processes that are available. And the ice you create is not a block ice, which is fixed to a heat exchanger surface, for instance. Instead, it's a pumpable water ice mixture. So it combines the best properties of chilled water and of block ice. So on the one hand, you have the high energy density, and on the other hand, you have the possibility to pump it through pipes. Another very important feature is that this process uses water as refrigerant, which is very sustainable, of course, and also safe because there are known toxic or flammable refrigerants in this process. So what can be done? First application, of course, is the cold thermal energy storage for load management, or you can also call it power to cold. If you have renewable electricity available during a certain time, you can store the energy as cold energy. You see here one of our commercial pilot projects, if you will. It's installed in a data center in Göttingen. And a nice thing about this technology is also that you can combine the three parameters of a storage system: the charging capacity, charging performance, the storage capacity and the discharging capacity in any way you want, more or less. Also because the storage medium, the ice slurry, is pumpable. And another very interesting application is about heat. So this process can make a lot of sense in heat pump applications because every heat pump needs a heat source. And especially for larger scale heat pumps, air or also the ground, using these sources for a heat pump has some disadvantages. And if you have a water body available, so a lake, a river, or even the sea, then this water body is a perfect heat source for a heat pump, but it has the problem that during the winter, of course, the water becomes cold. And if the water reaches a temperature of about 6 to 5 degrees, with conventional heat pumps, it's not usable anymore, so you need another solution. Using the vacuum ice or triple point process, however, the heat is extracted from the water not by reducing the temperature, but by freezing the water. So you take out the latent heat of freezing to transfer the energy to the water vapor and then give it to a heat pump. And you can see it quite well here with the temperatures. So you can even use 0-degree water. You can take out of this water 400 kilowatts of heat, and you return the same mass flow, but with 30% ice to the water body. Attached to this plant, of course, you need an downstream heat pump, which then generates out of this temperature level more or less every temperature level you need for your heating purpose. For this application, we also have a first reference. It was a proof of concept installation done 2 years ago in the city of Zittau, together with the local district heating company. And we used this small river here, it's the Mandau. And here you see also some ice that was not given back to the river. Usually, of course, it was given back to the river. Here you see the ice-water mixture flowing in a pipe. Our current project, we realize, is a project in Bremen using water from the river Weser. It's called the Überseeinsel, also has their own website where you can look at. And here are some impressions from this installation. It's still under construction, and we hope that it will be in operation in March next year. And last point, we already founded a spin-off company because we are a research institution. The name of the spin-off company is aquathermie, and this company is available for commercial and also for research and development projects throughout Europe. So what are we offering? We means ILK and aquathermie. We could be your partner for commercial projects with ice slurry or with water as refrigerant. May it be for cold thermal energy storage, for combined heating and cooling, which brings very high efficiency, or for the aquathermie applications I just explained. And we are also available for European research projects to demonstrate these applications or to even develop further applications. Some of them I mentioned here, like district cooling, mine cooling, seawater desalination, or even the production of technical snow. Thanks for your attention, and if you have any questions, then I will be happy to answer.